Hi Christine, this is some feedback for the three questions that you sent through the email about. So with this first one regarding this maximum area problem, you are correct in identifying that this is the height and the width is 2u, but when you did this you didn't put a bracket around this because it's going to be 2u times all of that. So this expression is going to be incorrect because it's 2u times 12 as well as 2u times this. Now, in preference to doing it like this, actually do it on your calculator. So I've got here 2x times bracket, derivative equals to 0, solve for x. So x is going to be 2 root 3 on 3, which is the same as 2 on root 3. So it's going to be this answer or this answer. And if I sub that in, given x equals this, I get this answer, which is 32 on root 3, which gives me this answer. Now, if you didn't want to do derivatives, you could have taken your expression for the area and gone up to interactive calculation Fmax, and it's going to tell you, it's going to be infinity, isn't it? So it's going to go from 0 to 2. So I'll do that again, from 0 to 2. XC, and there are the two answers that I was looking for, maximum value and the value that exited occurs. Okay, so that's that question. If I come over to the multiple choice question about the binomial, I've got two bags, there's 20 marbles, n of them are blue. So probability of blue is n on 20. Probability of not blue is 20 minus n on 20. Okay, I'm choosing 5, but it's with replacement. They're returned, so the probability stays the same. So blue is binomial 5, and it is n on 20 as the value of p. Now I don't know whether n equals one of these, and you are correct in identifying it is conditional. However, it's 3 or more, so I need to include 3, given that it's more than 1. So this is the probability that blue is bigger than or equal to 3, given that blue is bigger than or equal to 2. So I need to round that up, 0.48. So on my conditional, 2, 3, 4, 5, bigger than or equal to 3 are these 3 results. Bigger than or equal to 2 are these 4 results. The overlap is probability that x is bigger than or equal to 3 over the probability that x is bigger than or equal to 2. So I've got the binomial CDF from 3 to 5, where I've got 5 and it's n on 20, over binomial CDF 2 to 5, where n is 5 and that's n on 20. So what I'd like to do is grab my calculator, and I might put that there so I can see all of these choices. So bring up my interactive distribution discrete continuous CDF. Lower is, the top one is 3, upper is 5, n is 5, and I'm going to start with 5 on 20. And go OK. And then I'm going to pick that up and put that into the denominator as well, and make that 2. And did I get 0.48? No. So it's not 5. Now I'm going to try with 8. And it's just quickly trial and error to try and find 0.48, and there it is, 0.4787. So 0.48 So my answer is B is 8. Okay, now I'm coming to the short answer section. And it comes out of question 1. I've got this rule here, and I've got this tangent that's been applied, and the equation of the tangent will be, so I've got square root of x, open a bracket, 2 minus x, and then I've got e to the minus 2x. Press X here and make sure it's exactly what I want. I might even graph it and make sure it's the same thing. And it looks like it, doesn't it? So I want to know the tangent at 1. So analysis, sketch, tangent at x equals 1. Okay, and there's my tangent line. When I press X here, I get an equation of it down there, but it's not exact. So I'm going to take this and I'm going to go interactive calculation line, tan line at x equals 1. And that's the equation of the rule. So I've got y equals minus 5 on 2e squared x plus 7 on 2e squared. That's the equation of that line. Okay, so now we've got r is on the tangent. So r is somewhere on this tangent. And that's got the coordinates r and s. And it's the point that's closest to the origin. So r could be up there, but that's a long way away from the origin. It's likely to be somewhere there in preference to somewhere over here, because the distance to the origin has got to be the shortest. So I know that r is the same as r and minus 5 on 2e squared r plus 7 on 2e squared, because the coordinate along this line follows this rule. So I'm interested in the coordinates of r and then the distance. So I need to do the distance rule. Now, the distance rule will be the square root of r minus 0 squared plus all of this minus 0 squared. So on my calculator, I'm going to have keyboard square root bracket x minus 0 squared plus bracket all of this minus 0, I don't need the minus 0, squared, xc. Now I don't care what it is. I wish to minimize it, so I might do derivative dx equal to 0. Solve for x. And that's the value of r, 35 on 4e to the 4 plus 25. So to the question, which was what's the coordinates of r, it's going to be, can't remember really, 35 over 4 e to the 4 plus 25. And the y coordinate will be, if I take the expression for the tangent, which is that one, copy it, come down and paste it, and then math 3 given, x equals that, take the brackets, well, it doesn't matter, press X, Simplify the answer. Oh, that's nicer. 14e squared on top of 4e to the 4 plus 5. So that's the coordinates of R, and find the distance. Well, I have an expression for distance. The expression for distance is this expression here, so I'm going to copy that, go down and paste, and then math 3 given, and x equals this value. Copy that, and paste. XE, simplify the answer, that's nice. So the minimum distance is 7 over the square root of 4e to the 4 plus 25. So I needed to use the equation of that tangent and then use the x and the y coordinate because the point R is going to be on this line. Hope that helps.